Okay, let's give you guys some more practice. So this is a graph tan of x. So work out this area here. Work out this area from 0 to pi over 2. From 0 to pi over 2. Remember that on pi over 2, tan of x breaks down. So there's a vertical asymptote here. So but somehow work out the area from 0 to pi over 2. From 0 to pi over 2. So press pause and have a go. Okay, so to do this, our normal routine has always been to integrate it from 0 to an arbitrary point, let's say b, and then later on allow b to head towards pi over 2. So rather than, because dead on pi over 2, this thing here breaks down. So we are going to integrate it from 0 to b. So we are going to integrate it from 0 to b. So to integrate this, visualize tan of x as this thing here. Now, if you look at this, to integrate this, if you look at this, this is almost the exact derivative of this thing here. So if I were to give you a natural log of a bubble and ask you to differentiate this, you would go 1 over the bubble and then times the derivative of the bubble itself. So because this is almost the exact derivative of this thing here, well, if this is cos of x, then this must be cos of x, and then this must be the derivative of this thing here. So that would be minus sine of x. And then if you look at this here, this is almost the same as this. So you would somehow try to negate this negative. So you would then go back to your initial guess. And then make the adjustment. Stick a negative in here. Now, when you differentiate this now, this negative here disappears. So now you've got sine of x over cos of x, sine of x over cos of x. You could use integration by parts, but if you glance at it and you can see that this is almost the exact derivative of this, then just integrate it straight away rather than using integration by parts. So integrate this. That will then give you the absolute value of whatever this thing is here. But then if you look at what we're doing from 0 to b, from 0 to b, we're never going to enter the negative realm here. So we can ignore the absolute value here, the absolute sign here. So this thing here will just tidy itself up. So now you can take this out. So that will then give you this. So now put the b into here. So cos of b, and then put 0 into here. So put 0 into here. So cos of 0 will be 1. So you've got natural log of 1. You've got natural log 1. So now natural log of 1. If you look at the natural log graph, it looks like this. Natural log of 1 is 0. So this thing here is going to disappear. So this thing here will then become this. So now, so when you integrate it from 0 to b, it will give you this thing here. Now allow b to move towards pi over 2. So take the limit as b heads towards pi over 2. Well, the minute you let b head towards pi over 2, this whole thing here will become this. So rather than you integrating from 0 to b, the minute you allow b to head towards pi over 2, you are actually integrating from 0 to pi over 2. So the minute you let b head towards pi over 2, this thing here becomes this, and then you can then take the limit. You can then take the limit as b tends to pi over 2. So this thing here will then become this. Okay, so now if you look at this here, as b heads towards pi over 2, cos of pi, well, if you look at this bit here, cos graph looks like this. So this here is 2 pi, this here is pi, this here is pi over 2. So as b heads towards pi over 2, this thing here is heading towards 0. So this thing here is heading towards 0. So this thing here is heading towards 0. And then if you look at the natural log of x looks like this. Now as you're heading towards 0, remember natural log of 0, as you're heading towards 0, you are heading towards negative infinity. Well, if this thing here is heading towards negative infinity, you've got a negative here, making the whole lot head towards positive infinity. So as you take the limit, as b heads towards pi over 2, this whole thing here is going to head towards positive infinity, meaning the area is going to get larger and larger and larger and larger. It doesn't converge. The area doesn't converge. So you can say that this thing here diverges. So that if you go back to the graph, as you approach pi over 2, the area is just going to get larger and larger and larger and larger. It doesn't converge. So it doesn't converge.